It's a lightweight language that is simple to learn and popular amongst developers. It's a text format for storing and transporting data, and since it's textual data, it makes very easy movement data content between environments. It was originally derived from JavaScript. It's very easy to read and write and pass between computers. And here we're mentioning that it's very portable with all platforms and languages. In other words, it's platform and language independent, meaning we can use it pretty much on any environment. Okay, so the basic syntax rules for JSON are that data is in a name value pair. So we see here the name value pair is separated by a colon. Data itself is separated by commas. We see here the curly braces represent objects and square braces hold arrays. So the specific arrays and object operators that we use within JSON, which we know is, we don't have that in XML. Okay, so the first diagram here, we see the object construct here. We see that we have a name value pair here. We see the curly brace. The name is separated by a colon with the value. And we also see that if there's any additional name value pairs within an object, they're separated by commas. And typically JSON strings are written in double quotes and numbers are not. That's for the value. The second diagram shows an array, which is a grouping of data. We note square brackets for the array. That indicates that the array is beginning. So if we see a square bracket, we know that we're beginning an array. If there are an additional name value pairs, we also see the comma here. An example of array would be a list of employees, which would include for every employee a first name, last name, employee ID, employee phone number, and address. And we would have repeated values for each employee. So that would represent a grouping of data, which is an array. The third diagram shows that in JSON, the values can be any one of the following. It could be a string, number, object, array, true. It could be a Boolean, true or false, and null. Okay, so this is further examples of understanding JSON structure and syntax. So for the value, we can have here numbers, and we see numbers aren't surrounded by double quotes. We see strings are surrounded by double quotes. Also, dates would be surrounded by double quotes. Another potential value is Boolean, true and false. The green square here shows an example of an array surrounded by square brackets. And we see in here each value is separated by a comma. In the magenta or red square, we have objects which are separated by curly braces. In the second example, we see that we have two name value pairs, the name and age, and we see that John is a character, so it's the double quotes, and 31 is a number, so it's not double quotes. The third example here, we see that we have an object with three name value pairs, and we see the first pair has an array as the values. And the final orange block shows here at the bottom, the ID is a number, and we also see the date as surrounded by double quotes. Okay, so this is further examples how we specify JSON. Okay, the first example is an object because it's surrounded by curly braces. We show that there's one name value pair. The key, which is also the name, so it's used interchangeably. We can see that someone say key and someone says name. That would be the first name, and the value of the string is John. The second example is another object, which we have three name value pairs showing the values of each, but both as a string. and as a number. And the third example shows the employees array as a square bracket with two sequences in the array, and each sequence consisting of a first name, last name, and age. Okay, so this is just further example of a JSON document which describes a book. Okay, we see it always begins with an object by the curly braces. Then we see there's several name value pairs, for example, title and as a name and the cuckoo's calling as a value. We have a detail object here within the original object, which also contains name value pairs. We also have a price array here with two sequences of arrays of values. Okay, and then basically, we kind of go through here. We see the array starts here and ends here. So basically, there can be many nestings within the document. And since we understand XML, this concept is not that foreign for us to understand. But sometimes when we get a large document like we do in XML or JSON, it can be useful to go into VI, and we can use the shift plus percentage sign. If we put our cursor here on this object and we want to see where the object ends, we could shift plus percentage sign and it would take us down here. So then we can link up the associated objects or arrays or whatever we would like to do. Okay, so the comparison between JSON and XML, since we understand XML's been around a lot longer, since 9203, versus JSON's been around basically since 12102. They can both receive data from a web server. They're self-describing and hierarchical. That basically means that we can have values within values, and they're both platform independent and can be passed by a lot of programming languages. The differences is JSON doesn't use end tags. JSON is short and typically quicker to read and write. XML is usually larger and more complex. XML has style sheets, whereas JSON does not. And XML can be passed by an XML parser, whereas JSON can be passed by a standard JavaScript function or anything that can basically read a text data. Okay, so the visual differences here. Okay, so these are the same. This is the JSON version, and this is the XML version. Okay, so we see we have an employees object with an employee array. We have two iterations of values within the array, and that consists of first name, last name, and age. As we see within JSON, we have specific operators for whether it's an object or an array. Whereas with an XML, there's no specific operators to show us whether it's an object or an array, and we basically just have to understand it based on the contents of the document. Okay, so how does Oracle integrate JSON into the database? Okay, so we'll discuss the 23c. There's a new data type called JSON data type, but prior to this, we had to use either a textual data types like varchar and glob, and we also have the option to do blob and b file. The example down the bottom just shows the JSON check constraint to ensure the JSON document is syntactically correct and well-formed. A well-formed JSON document means that it has valid arrays, objects, name value pairs, etc. And here we're just listing the syntax to ensure that we're only seeing well-formed JSON documents to be inserted into the J purchase order table. Okay, so here we're listing the rules for which we wish to search on a JSON document, or the standard syntax required to do that. So within this, we always start with a $sign to start a path expression. We can step through via dots to navigate inside an object within the curly braces. We specify a number inside the square braces to navigate what part of the array we want to look at. An example here is we're using the dollar to start the path expression. We're going to the second iteration of the phone numbers array. We should note that it starts at 0. So 0, if it was 0 here, that would be the first iteration of the array. Then we wish to go to the type. We would like to bring back all the type information, whether we want to manipulate it or whether we want to just list it. And here is a bit more of a complicated one. We want to bring back all the contents of the phone numbers array as indicated by the wildcard. The question mark is a where expression within the path expression, where the type is home, and we want to bring back the specific values of the number key. So here we're providing the Oracle SQL operators to query JSON data, and that includes the simple dot notation, JSON value, JSON query. As we see, these kind of mimic what we use in XML. We also have XML query, XML table, XML exists, etc. And here we're just listing an example of the JSON table syntax, which is similar to XML table within XML. And this is when we want to put it into a table row column format, like what we usually use in the database. Okay, the simple dot notation is the most basic of queries. It only works if we have a JSON constraint. And in this example, we see that we have to set up the alias to the table. And here we want to go to the table JSON table. We want to go to the column doc, and we'd like to have the first name listed. And we do the same for the location and city. So we listed the first name and the city. Okay, whereas JSON value is a single scalar value, JSON query can be an array or object. In this example, we are listing the color tab table. We wish to go to the color column where we store all the JSON data, and we want to list the name values, in this case, which are black, orange, red, and dark orange. Okay, JSON query. This is where we would like to talk about the array and object. And here we wish to go to the customer data column from the customer tab table, and we'd like to list all the address values. And here we see it comes in the form of an object. Yeah, basically the dollar is whenever we want to do a path expression, we would list the dollar. That would signify that we're going to do a path expression. So here we're saying, okay, we're looking at the customer data column, and we wish to do a path. We wish to begin the path expression. We wish to step through the document. Okay, so this is the JSON table, which we're familiar with from XML table. And here we can have nested tables. We're going to do multi-level collections. Also, in this situation, we want to bring back it in relational data. So we have a JSON document. We want to bring it back as a table column format. And in this case, we're looking at the FB tab table, specifically the col column. And we want to look at the data array, and we'd like to see specifically message values in a relational format, which we do here. Okay, so here we're just illustrating that one row of output for each one row in the relational table contains JSON data. So in effect, we're converting JSON data into relational data. And there's also the capabilities to do the reverse, where we can use JSON object and JSON array. We also mentioned that in the demo. Okay, so talk about the 23 JSON new features here. We're going to talk about the new specific JSON data type, which is optimized to deal with JSON data just like XML type with XML data. We talk about the multi-value index and JSON transform, and then we talk about JSON schema, which is the same as XML schema. Okay, so we start with the new JSON type. Sometimes we see developments call it OSON, which basically just means optimized binary storage format. And compared to JSON's text storage, it delivers performance benefits to JSON as it includes faster query performance and more effective updates since it's binary and there's no need to pass the JSON text. We see here at the bottom of the slide, we are creating the new JSON data type here. Previous to 23c would have glob or varchar or blob or something here. And there are some limitations to the size of the new JSON data type. I ran into a customer a couple of weeks ago, and I think it's 32 meg, which is the maximum amount of size that we can have for the JSON data type. There's also the multi-value function text, and that is available in 23c. So prior to 23c, we only had the single value function, which we could do it on JSON value. As an example, prior to 23c, we could only do a index on a person. Since a person can only have one birth date, we would only be able to do a single value function index on a birth date, since it only contains one value. However, in a lot of cases, we wish to index all the elements of the JSON array. And in this example, we would like to index the entire credit score array. We have this option so that we can make sure that when we query it, we can use the index to bring back the values. We also have a JSON transform update option in 23c. That means that we can update JSON data types without any overhead of passing JSON text. And if possible, we try to do a partial update, which significantly improves performance. Whereas prior to 23c, we had to do a full update of the whole JSON document. So we had to, whenever we want to do an update, we had to bring the update out and then update it and then reload the entire document back. Whereas in 23c, we now have the option just to do this on a part of the document. And here, it's familiar, similar syntax. We're using JSON transform. The T represents the personal collection table. The JDoc represents the column. And we wish to step through by the $ to go to the person and then credit score. And we would like to go to the first iteration of the array and change it to 710. Yeah, this is a new function, JSON transform in 23c. And that would be the recommended way to do it, because we would only have to do a partial update versus updating the entire document, which previously, when we used an update on JSON document, it would bring the whole document out. So it'd be slow and inefficient. Okay, JSON schema. We have the JSON check constraint prior to 23c to make sure we have well-formed JSON data. But this JSON schema enables us to have rules and regulations for a JSON document, just like XML schema. So an important distinction here is for both JSON and XML that people will use the terminology well-formed. Okay, so well-formed just means that the document passes all the syntax rules. Okay, so For JSON, that would mean that we have the, everything is correct. We would have the correct usage of an object or an array. The name value pairs are correct. We're not missing a colon between a name value pair, as an example. So that would be a well-formed document. When a document is valid, that means that the JSON document adheres to the schema rules. Okay, so we're specifying that we would like the ID to be the first name value pair. We would wish the name to be the second name value pair. We would wish that the ID be a number. That's an example of a JSON schema. So basically it enforces rules on the document, whereas if it's well formed, that ensures that it's syntactically correct. Okay, this user JSON schema columns is a new view that we use to determine that we have JSON schemas within the database. Obviously, there's user, all, and DBA we can have here. We also have the function DBMS JSON schema is schema valid, just to, if we want to look at a document, confirm that it's valid, it would come back with a yes or no. And we also have a new DBMS JSON describe to show us how to generate a JSON schema definition based on JSON documents or relational data. And in this case, we're just doing it on the EMP table. Okay, now I'll go through a demo. So this is on 19. Okay, so hopefully we'll show you the JSON document here, and we'll show you how to step through the JSON document. First few lines, we're just setting up the demo. We're creating a user. We're creating the J purchase order table. We see it has 3 columns here. We're wishing to specifically store the JSON data in the PO document column. We want to set it as a CLOB data type, and we're using the JSON check constraint here. So we do check PO document is JSON. Okay, and this would tell us that the constraint would return true if the content of the document is well formed, and it would return false otherwise. Okay, and we see here the 3 columns that we set up, and we see it's a CLOB. Okay, so the view user JSON documents shows all the JSON check constraints within the database, the associated table name and column name, the format, since we can store it as blob or B file, it could be binary, but in this case, because we did it as CLOB, it's as a textual type. And we see here the data type is a CLOB. Okay, and here is the JSON document we're inserting. We can also use external table, but in this case, we're just doing an insert into. And this is a typical JSON document. Okay, so stepping through here, we have several name value pairs. We have the shipping instructions object. Okay, within that shipping instructions, we have a name value pair, we have an address object, and we have a phone array in here. We also have a couple other name value pairs, and then we have another array, line items. And that consists of 2 different iterations. Okay, so if we want to use the dollar, then we decide how we want to step through this, it would depend on the hierarchical nature of it. So if we wanted to do $, and we wanted to do a where clause on this, we would just do $.PO number equals 1600, or $.PO number, and that would take us to this 1600 value. If we wanted to go to the name under the shipping instructions, we'd do the $.shipping instructions .name, and that would take us to Alexis Ball. Okay, so that's kind of what we would do with the dollar symbol. We'd do the $, and then we'd go to the certain area depending on the hierarchical nature of it. It can get pretty confusing when you've got a really big document, how to step through it. There's a lot of JSON editors online you can use, free JSON editors, and also XML Spy has that capability. I use XML Spy quite a lot, and that enables me to determine, where I can go next within stepping through the document. So that's kind of a useful tool. Okay, here we have the is JSON. We're using it in the where clause. Okay, so here we want to make sure to check if the document is well formed. And since the J purchase order is well formed, we're getting the entire document back because we're just doing a select on the column. Okay, so here we're using the simple dot notation. This is the simplest form of queries. In this case, we have to use the alias for the table J purchase order. We're going to, therefore, the J purchase order table. Then we're going to the specific column, which is PO document, where the JSON data is located. And we're wishing to go to the cost center. Okay, and we see that the value for that is the cost center is A50, and we're also doing a count on that. There's only one cost center name value pair in here, so we get the value of 1. So this query here, we are basically showing how to fetch the JSON document where the PO number key has a value of 1600. Okay, so that's also bringing back the entire document. Since we're specifying here PO document, we want the entire document where there is a PO number of 1600. Okay, this JSON value shows us selecting the cost center. Okay, we're going to the JSON value, we're going to the column, and we want to go to the cost center and also the count. And this is the same query around when we run the simple dot notation. Since there's only one cost center of A50, and there's only one of those. Okay, this next query here is probably the most confusing thing within JSON. So in this example, and this happens to customers quite a lot, is we're getting a null result on this particular query. Okay, and the reason is that we see here we're specifying JSON value and we want to bring back the shipping instruction dot address. So we want to go here, shipping instructions dot address. So we want to bring back all this information. However, since we missed out the S, we only have shipping instruction. So therefore we're getting null results. Okay, so since the JSON path expression does not match the scalar value, the null on error behavior kicks in. Okay, and this is the default when we run queries, null on error. basically implies that if an error is returned while applying a JSON path expression, then the result is assumed to be null and no error is raised. Okay, but in a lot of cases, we would like to see why we're not getting the data back. Okay, so in that case, we would have to specify the error on error syntax. So we specify that error on error syntax here. And we can use this error, we can use null on error on error syntax using JSON value, JSON table, JSON query. We can use it on all the operators. But in this case, we want to see why we're not getting any rows back. And since the JSON expression does not evaluate to the scale of the value, we get the error on error, and that indicates the error is JSON value evaluated to no value, an error 40462. Okay, we also have JSON query, like XML query, whereas JSON value can only extract the scalar value. JSON query can return an object or an array. And in this case, we're wishing to bring back all the contents of the shipping instructions. So we're going to bring back all this information here. Which we see here as it comes back in the form of an object. Okay, so we're showing the JSON table example here that's used in the from clause here. And it enables the creation of a relational view of the JSON content. Okay, so we use the expressions here in order to map the JSON document into a column row value response. So here we're wishing to go to the, we want to list all the line items. We want to go to the line items array, which is here. And we want to manipulate all this information under here. And we want to specifically go to quantity here. And we also want to go to the unit price, which is here. So we wish to list those values. And we see here the unit price is 19.95 and 9 for the first parts of the array. And then we see that it is 5 here quantity and 19.95 here for the unit price. Okay, here we have the JSON exists here. And here we use it in the where clause. And here we want to bring back specific, we want to tell whether the JSON document matches a JSON expression. And this query counts the, we want to go to the shipping instructions key. Okay, so we want to go here. And we want to specifically go to the address here because we're stepping to the second part of it. And then we want to go to the state here. And we want to list the count on that. And we see that it comes back as 1. And constantly get the result 1 here. Okay, here we're creating an Oracle text index as indicated by the CTX context. And we can tell that it's a JSON Oracle text index by this JSON section group. And we're using the sync on commit, meaning that whenever there's an update or a data manipulation on the data, it would immediately go into the index. Okay, here we're doing a query, which we will So basically here we're using the sum of the quantity times unit price. And we want to use the same query we used before with our JSON table, the line items, the quantity and price. And since we're doing this, the quantity times unit price, we're doing the 9 times 19.5 plus 5 times 19.95, and we get the value of 279.3. Okay, we're using the auto trace explain here. We want to show that when we run this particular query up here, that we're actually going to use the index and we're going to get a good plan. And this shows us that we're actually using this domain index that we just created to bring back this result. Okay, we also have some JSON generation functions. So the JSON value, JSON query, JSON table takes JSON data and returns it more in a relational type format. We have the option to do the opposite and take a relational data and return it into JSON data, which I think is a big advantage for Oracle over some of the other competitors like MongoDB. Okay, so here we're creating a customers table. We're doing bar charts, etc. And here we're using JSON object because we would like to create an object based on the relational data. And we're specifying here JSON object. We're listing the name, and the value relates to the column name. And then here we're doing the name, and we're concatenating first and last of the columns. And we want to call it joined, the name, and we want the value to be join date. Okay, so that's creating JSON objects. And here we finish up with a simple JSON array where we're basically creating first and last and creating an array based on that. Are there any questions on the demo part of it? Okay, so common customer problems. We have our notes. It was offered in 12.102. We did have some JSON patch bundles which they allowed us to create, which are basically large number of fixes, and we merged that into DBRUs. We have some frequently asked questions, and we have a JSON health check script now, like we have for all our components. Like all content management issues, we usually need a test case. The JSON installation issues are pretty common errors we get, like all the invalid components. We typically want to look at the invalid objects, DBA errors to see why they are invalid. And then we can often run a lot of the scripts, rerun the scripts if we're getting invalid objects, depending on the reason why they're invalid, which we decide, how to handle the problem. And there's also quite a few issues where customer needs help rewriting their JSON. So, we need to often get the test case and maybe step through the document. Some people, as already mentioned, would get the null on error, so they would get no results. They're wondering why they're not getting an error message, so we need to bring it in-house. Set up their data, making sure they're stepping through, making sure that maybe they want to see error on error. They're kind of common problems we run into. Here we have, this is the documentation. We have some blogs. We have some notes. And